Picture the most violent volcanic eruption in human history, Mount Tambora, 1815. It darkened the sky for an entire year. Crops failed across continents. 70,000 people died. The summer of 1816 simply did not come. That is what a single eruption, one eruption, can do to an entire planet. Now imagine that energy, multiply it by 10,000, and imagine it happening constantly. Not once in a century, not once a year, but right now, at this very second, while you breathe, while you read this, while the world outside your window sits quiet. This is not a planet, it is a moon. A small, strange, burning moon trapped in the grip of the largest planet in our solar system, and it has been burning since before Earth had oceans. When the Voyager spacecraft first sent back images in 1979, scientists were stopped cold. Io was not what anyone expected. It was not gray and barren like our moon. It was not cratered and rust-colored like Mars. It was yellow, orange, white, splashed with deep red and pale green and burnt sienna. One NASA scientist, in the stunned silence of the control room, looked at the image on the screen and called it a pepperoni pizza. It is an apt description. From a distance, Io looks like something from a dream, a moon painted by an artist who had never seen restraint. It is the fourth largest moon in the solar system. It orbits Jupiter alongside three other great Galilean moons, and in composite images, it appears almost peaceful, a jewel drifting serenely against the black. The yellow is sulfur, the orange silicate lava fields, the white is sulfur dioxide frost, settling like snow across the highlands. The red, deep, ancient, arterial red, is the residue of long-chain sulfur molecules, deposited by eruptions that have been happening for longer than anything alive on Earth has existed. Do not be fooled. What looks like a colorful painting is in reality an ever-changing surface of death. The colors are not geological history. They are not ancient. They are fresh. They are last week. They are yesterday. The beauty of Io is not preserved. It is produced, continuously, violently, without pause. The beauty is built entirely from violence. Io has more than 400 active volcanoes. Let that settle. Not dormant, not extinct, active. More active volcanoes than every planet and moon in the solar system combined. Its lava reaches temperatures of up to 1,600 degrees Celsius, hotter than the lava produced by Earth's most powerful eruptions, which average closer to 1,200. The rock on Io does not cool, it cycles. It erupts, briefly solidifies, and is swallowed again. Consider Loki Patera, a lava lake, a single, continuous lava lake, roughly 200 kilometers across. That is larger than Lake Ontario. It does not erupt in columns. It erupts in slow, unstoppable waves that roll across the surface of molten rock like a tide across a Black Sea. It completes a full overturning cycle, approximately every 400 to 600 days. It has been doing this since before the Roman Empire existed. Consider Pele, the volcano named for the Hawaiian goddess of fire. Its eruption plume rises 300 kilometers above the surface. 300 kilometers. The plume of Mount St. Helens in 1980 reached roughly 25 kilometers. Pele's column of gas and debris reaches 12 times higher, bleeding into the vacuum of space. And here is the detail that makes geologists go quiet. There are no impact craters on Io. None. Not one. In a solar system billions of years old, on a surface bombarded by debris since the beginning of time, there is not a single preserved crater. The lava has erased all of it. The entire surface of Io is repaved by volcanic activity every few thousand years. Every scar, every mark, every record of what came before, gone. Io has no water, no breathable atmosphere. Temperatures on its surface swing from negative 143 degrees Celsius in the shadow zones to over 1,600 degrees Celsius at active vents, sometimes within a matter of kilometers. Io is not a world, it is a furnace. And the furnace never goes cold. The question that keeps planetary scientists awake is not what is happening on Io, it is why. Why won't it stop? The answer is Jupiter. Io orbits Jupiter every 42 hours. Europa, the next moon out, orbits in almost exactly twice that time. Ganymede orbits in 4 times Io's period. This alignment is not accidental. It is a gravitational lock, a resonance, and it has been synchronized for billions of years. And that synchronization is a sentence. Because Io cannot simply orbit. As it moves, Jupiter's immense gravity pulls at it, stretching it, warping it, deforming it. Europa and Ganymede tug from the other side. Io is caught between them, flexed back and forth with every single orbit. This is not a metaphor. The solid rock surface of Io physically rises and falls by up to 100 meters with each revolution around Jupiter. The ground itself tides, like the ocean surface on Earth rises under a full moon. But here, it is rock, solid rock, heaving upward and crashing back down, kilometer by kilometer, every 42 hours. This is tidal heating. The constant deformation creates friction inside Io's interior, and friction produces heat. Enormous, inexhaustible, catastrophic heat. Io cannot radiate it fast enough. It cannot cool. It cannot release pressure and settle. The heat keeps building. The interior stays molten. The volcanoes keep firing. Imagine someone grabbed your body and squeezed it. Hard. Then released. Then squeezed again. Released. Every single day. Not for a year. Not for a century. For 4 billion years. You would not simply be exhausted. You would not simply be in pain. You would be nothing but heat and ash, scattered across the floor of the universe. That is Io. Io has no choice. It cannot leave Jupiter's gravity. It cannot break the resonance with Europa and Ganymede. It cannot stop the tides from rising through its own body. It is trapped in a machine it did not build, burning for reasons it cannot control, with no end in sight. 4 billion years. And counting. Imagine standing on the surface of Io. Imagine surviving the journey, the months in transit, the approach through the outer solar system. And now, you are here. You are standing on the most volcanically active body ever discovered. The first thing that kills you is invisible. Io sits deep inside Jupiter's radiation belt, a zone of charged particles trapped by Jupiter's enormous magnetic field. The radiation dose on Io's surface is approximately 3,600 rem per day. The total dose that will kill a human being is around 500 rem. You would receive a lethal dose in less than 4 hours. Your spacesuit would begin to fail within hours. Your electronics would die. Your instruments would go dark. But suppose, for a moment, that you could not die from radiation. Suppose you were immune. What would you see? The ground beneath your feet would be moving, not shaking. Moving, rising and falling in a slow, enormous tide, 100 meters over the course of hours, so gradual you might not feel it at first, but so vast it would be visible in the distant ridgelines shifting against the sky. In every direction, lava. Lava lakes boiling and rolling in slow spirals. Volcanic plumes climbing hundreds of kilometers above you, catching whatever thin light reaches this far from the sun and scattering it into sulfur-colored halos. Sulfur dioxide snow drifting down from eruption clouds overhead, settling on the plains like pale ash, and dominating the horizon, consuming it, Jupiter itself. An enormous banded giant, 60 times wider in your sky than our moon appears in ours, its cloud bands swirling, its storms larger than Earth, its gravity invisibly threading through you, through the rock beneath you, pulling everything it touches slightly toward it, always toward it. You would be standing on the most hostile ground ever discovered. You would be cooking alive in radiation you could not see. The world beneath you would be moving. The sky above would be on fire. This is not a hell from mythology. This is a real place. And it is 628 million kilometers from where you are sitting right now. When Voyager 1 flew past Io in March of 1979, the scientists in the control room at NASA's Jet Propulsion Laboratory expected to see a dead moon, cratered, silent, gray. Navigation engineer Linda Morabito, examining a post-encounter image, noticed something wrong at the edge of the moon, a faint, enormous, umbrella-shaped cloud rising above the limb of Io. It was a volcanic plume. A moon was erupting in the outer solar system. No one had predicted this. No one had imagined it. It remains one of the most genuinely shocking discoveries in the history of planetary science. The Galileo spacecraft followed, orbiting Jupiter from 1995 to 2003. It flew past Io multiple times, mapping the lava lakes, measuring the heat flux, documenting the sheer scale of what Voyager had glimpsed. The data confirmed everything and exceeded every estimate. More recently, NASA's Juno spacecraft, designed primarily to study Jupiter itself, conducted close flybys of Io in late 2023 and early 2024, capturing the most detailed images ever taken of its volcanic surface. New eruption sites, new lava flows overwriting the maps made just years before. A proposed future mission, the Io Volcano Observer, or IVO, would dedicate an entire spacecraft to studying Io up close, answering questions we still cannot answer. How deep does the molten layer go? How much heat does Io actually generate? What does its interior truly look like? But perhaps the most remarkable thing we have learned from Io is what it tells us about somewhere else. The same tidal heating that tortures Io almost certainly warms the subsurface ocean of Europa, the ice moon directly adjacent to it. The same mechanism likely keeps the ocean of Enceladus, Saturn's moon, liquid beneath its frozen shell. Those oceans are the most promising candidates for extraterrestrial life in the entire solar system. Io burns so that elsewhere, in the dark and quiet beneath ice, something might swim. The most violent place in the solar system might be the very reason life exists somewhere nearby. Io will never know peace. It is locked in a gravitational dance it cannot escape, burning from the inside, its surface never allowed to cool, never allowed to settle, never allowed to rest. Every few thousand years, the entire world is remade, every scar erased, every feature buried under new fire. It begins again, and again, and again. We look at Io, and we see violence. We see destruction. We see a world under siege by forces it cannot comprehend and cannot resist. But perhaps we are looking at it wrong. Perhaps Io is simply the most alive place we have ever found. It breathes fire. It reshapes itself. It produces more geological energy than every other solid body in the solar system. It does not merely exist. It transforms constantly, endlessly, with a ferocity that makes Earth's most catastrophic moments look like whispers. In some strange way, Io reminds us of something here on Earth. Not a place, a feeling. The feeling that some forces are so much larger than you that struggling against them is not just futile, it is inconceivable. Jupiter does not know Io is in pain. The orbital resonance does not consider what it costs. The universe does not negotiate. It does not pause. It does not care. And yet Io burns on, in silence, endlessly, 400 volcanoes firing into the dark. There is something in that, something worth sitting with. Keep looking up. The most violent place we know is also one of the most alive, and perhaps that says something about violence, and perhaps something about life.